Hi, Tony from All the Remote Things. I'm back again today, and I am so happy to have Jess Kerr with me. She's a software developer, speaker, and most importantly, something we're going to talk about today, semanticist. But how are you today, Jess?
I'm fantastic. It's been a rough morning. It's very wet here, very, very wet in St. Louis today. But the sun has come out in the afternoon and things are starting to dry.
Oh, brilliant. Yes, it's been a long time since we've seen each other. We caught up, we were just trying to work it out, 2016, 2018, maybe somewhere around there in Yao, Australia. We caught up and it was on a podcast that I work on as well. But since then, things have changed and the world's gone into remote. So I thought it'd be fantastic to talk to you again. Just, would you like to give everybody just a little taste of who you are and where you came from, and what you're doing?
Oh, sure. I'm Jessica Kerr on Twitter. That's Jessitron. And currently I work at Honeycomb. It's my first official developer relations job. And I love it because it's about observability. It's about teaching the software to teach us what it's doing. It's very exciting. But in my background, I've done, 10 years of enterprise Java development and a lot of work at startups and enterprises. And 10 years now speaking at conferences, which is
Yeah.
great because I get to meet people like you.
Well, that's fantastic, and thank you. So, I think one of the things we're going to start talking about was when we last met. Symmathacy was something that you were talking to everybody about, and it was sort of in its embryonic stage of being promoted out there. Let's talk about that. Firstly, for those that haven't come across it, what is it, and where did it come from?
Okay. So the word Symmathacy, it's spelled Symmathesy, comes from the Latin words sim, together, and mathacy, learning. This word was coined by Nora Bateson. She's an anthropologist. Her father was Gregory Bateson, and her grandfather was William Bateson, who coined the term genetics. And Nora Bateson created this word because she grew up steeped in systems thinking, but she recognizes that thinking about systems can be stultifying when we get the idea that a system could be understood. Because if you look at a system as a machine or an individual piece of software, a program, it may be really complicated, but hypothetically, you could eventually get an idea, an accurate idea of how it works by understanding all the parts and all the relationships between the parts. But there are plenty of systems that is not true of, systems that are constantly changing, and you'll never get a good idea about all of them. Little things like biology, any living thing, a person, a team, a community, the important stuff. So she coined the term Symmathacy to mean a learning system made of learning parts. So you can't even like get a really good grip on one piece of a team. And anymore, you can't get a really good grip on a distributed software system because each of the parts is changing. We're deploying stuff, we're updating. Um, Nothing holds still. And to work with the learning system of learning parts, you have to be learning too all the time.
That's
And to
brilliant.
work in one, even more so.
So taking that, how are you applying that when you're working with teams and in your role at this moment? And then the other thing is, I know you've been doing this for some time. How's it evolved since the last time I talked to you?
Mm. Okay, so Symmathacy, what's useful to me about this concept of recognizing that my team is a learning system made of learning parts. For one thing, obviously the people are learning parts, but I also include the software on the team, the running software, and it learns from us because we change it. That's our job as developers. We learn from it at a minimum of when we get paged because it threw an exception too many times, or the data it changes, or the logs, or in a modern state-of-the-art software system, the observability, the traces, and all the events that it emits, the software can teach us what's going on. if nothing else, your automated tests are teaching you what's going on. There's a lot of software that we write or write or configure or use in order to find out what's going on. So the software is part of the learning system. We can maximize that learning by being able to change it quickly. One property of a Symmathacy is as a system, like systems have different ways of getting bigger. And the economy gets bigger when more money moves around, and we call that GDP.
Yeah.
Ecosystems get bigger with like more carbon flows, and they get like richer and more different animals all eating each other and plants. Symmathacies get bigger with more learning flows. Not by adding people, not even by adding relationships between people, but by facilitating more learning in those relationships. So faster feedback loops, such as unit tests and shorter build cycles, and having a customer or a customer representative right on the team. So as soon as you change that UI, you can put it in front of somebody who can say, well, that looks weird, or, oh yeah, I get it. Yes, so maximizing the flow of learning, and that like changes how we orient our tasks sometimes, and especially our automations. I think you also asked like how
Where
it's
are you headed
changed.
with it? Yeah, where are
Where
you
am I
headed?
heading with it?
Where's it
Okay,
evolving?
so one thing about the concept of Symmathacy is I can draw like a bunch of people and a bunch of software and little flows of learning between them. And I can value those flows of learning, but it doesn't give me like a lot of concrete steps of what to do next. And so I've been looking for like ways to get more structure around that idea. And I've found one in a surprising place. Found one in a book about games. This book is called Games: Agency as Art by C.T. Wynn, amazing philosopher. That he's got some stuff that's even more important than this book. But this book is fun because it describes games as art, and not just art in the pictures, not just art in the story. The medium of games is player experience. Each game gives you a different experience as the player. So you can play Breath of the Wild and love exploring the world and opening chests and slaying pretty monsters. Or you can play Darkest Dungeon and have an experience of delving through ancient caverns where your ancestor like unearthed terrible demons. And I mean, it's not as pretty an experience, but it's also fun. And the interesting part about this is that when you look at the player experience as an art form, C.T. Wynn describes it as you create that experience by offering the player a particular agency, a particular way of being in the world, something to shoot for, and specific ways of getting there and ways to not get there. So when you play a game, when you play baseball, you adopt a goal of running around the bases. And you also adopt ways of getting there involving hitting the ball and then running and then stopping. You don't just go out there and run around the bases. I mean, sometimes you do, but you don't call that baseball. And adding those, okay, so you've got goals, you've got abilities, things like hitting the ball, throwing the ball, running, and you've got rules. Goals, abilities, rules. Those are the three things. Rules are like you only run after you hit the ball. And if the ball gets to the base before you do and they catch it, you're out. With these three things, we craft experiences, and that includes how people experience the game socially. It includes whether they can enter a state of flow, because that's a big part of the fun of games is that they're just absorbing. I can open Valheim and spend half an hour mining copper and just be so relaxed. Doesn't happen if you really mine copper, but this the agency creating an experience reminds me of our teams, because in every team, as leadership and also as a participant in the team, we craft an agency and offer it to team members. As a member of a software team, I have to adopt the goal of making the software work well and making it do this particular thing that is the new feature of the month. And then I choose to accept the means given to me. Maybe it's a programming language. It's certainly a code base. We're all going to work together in GitHub probably, and we're going to deploy to this particular place, and we're going to use these tools, and we're going to do code review and work together in these various processes. So our tools and our knowledge and our relationships are the abilities that we have to reach our goal. And there's also all kind of rules that we put in front of ourselves, like the linter, Kerr, and our failing build, don't push on a failed build kind of thing. And those result in an experience. And if we can get an experience of flow for our team members, then they can do better coding. A happy developer is a better developer, and especially a developer that's engaged and able to move forward and get that feeling of, yeah, I'm getting better and I'm accomplishing something that you get. Like in Super Mario Brothers, I love this quote from the book. We are given the abilities to run and jump, and a world full of chasms to jump across and monsters to jump upon.
I love
Just
it.
yeah. What you're trying to accomplish fits your abilities so well in a well-designed game. Can we do that in our teams? Can we fit the abilities that we give people? For instance, if you want software to run smoothly, you want people to be able to deploy quickly, because then we can learn quickly from our software. We can roll back fixes, which means we can make more frequent changes, which means we can make smaller changes, which makes them safer. It matters what abilities we give people and what rules we ask them to follow. So that means all the principles, because there's this analogy that works between game design as a design of experience and team design. I can look at principles from game design and apply them to teams. Note, this is not gamification. You said I could curse.
Yeah.
Gamification. This is what I'm speaking about this year. I did a keynote at Agile and Beyond on this. Gamification takes the surface characteristics of games, points, leaderboards, competitions, champions, and it slaps those surface characteristics onto other areas of life. That's not what helps. We can go deeper and look at how game designers work, how they craft that experience, apply those principles to our teams, not the surface characteristics.
I like it.
Not just the ceremonies and the ticketing tools. That doesn't make you agile.
And there's one in particular you're thinking of, right? And continue.
A couple of them. There's more than one. But if you just if you copy the solution, you don't get the same result.
Yeah.
You don't get the same culture. You've got to copy the process, the questions that people ask. Copy the questions, not the answers.
I really like that, and I like that you're coming from the depth of coming from development and having been in that role, and now stepping up and then coming back into it like this gives you that unique view of how, I've worked with lots of development teams over the years, and they do tend to get crunched in that mix of well, you've got processes, and you should just follow them. You know how to do this stuff. Whereas they're not enabled. So I really like the way that you talk about that.
Right. How can we give them more abilities and not more rules?
That's it. Yeah, process and rules doesn't fix the issues quite often.
Right. It just slows people down.
That's it. That's
not just. There are rules that are constraining. that are useful constraints. What do we call enabling constraints?
Yeah.
Enabling constraints include you don't change code outside of version control.
Yeah. Yeah.
Because
The obvious ones
logging into production and tweaking that executable is not going to help
yeah,
anybody.
that's not they're not the ones we want to get rid of, but you know the type of process rules and I
Right.
think that's fantastic. Now I want to just pick you up on something you said just a little bit further back, and you talked about the code, and you have this thing that I've heard you talk about, and I've read some of your blogs on it, and it's teaching the code to teach us, which I think is a
Yes.
really unique way of thinking about it. Talk to me a little bit about that idea.
Okay. So like I used to work at a biotech firm, and the scientists there needed to inject genes into seeds, and they can they have these little gene guns, whatever, or they shoot like strands of DNA with laser thingies at the seeds. But did any of them land? Did any of them get incorporated into the DNA of the seed? Um, in order to know that, they put marker genes in. They include like bioluminescent portions, at least for testing. And then they can like shine black lights and find out whether the genes went in. It's really hard. Then they can't even use that bioluminescent stuff in the real production process. It's really, really hard to know whether you got 0, 1, or 100 copies of that gene into that seed. Biology is a amazing complex system that we have a really hard time learning about. It's just really hard to get down to the scale and figure out what's going on. Software, the software ecosystem or ecosystems like the internet, this is an incredibly complex system. There's so much going on. Even within most companies, our distributed software systems are really freaking complicated and surprise us in new ways every day. The difference is we have the ability to make it tell us what's going on. It is so much easier to insert a line of code than to add a marker gene and shine a black light on it and hope it works. That's part of the magic of software. The magic of software is that we can change it quickly, and we can use those changes to make it tell us what's going on. And that obviously helps in our Symmathacy. Shouldn't say obviously. That does help in our Symmathacy. And it helps tremendously when we're troubleshooting. It helps ops. It helps. Personally, I get really excited about, as a developer, having a much better understanding of a wider part of the code. I can't understand all the code. I can't understand all the systems that call my systems. But if I can see like a distributed trace and get like really good examples of what is coming into my system and what my system really does with it, it's very satisfying, and also helps me make safer changes, helps with onboarding. It just generally makes the software feel like part of the team.
I love that you're so passionate about it. I want to come work with you. Every time I talk to you, it's like, oh, I'd love to work with you. My question there though, why don't more developers do that, or more organizations do that? So that's a
So we
very good
do.
question for me.
We all do. Hopefully, we at least log, right? We're used to logs. We're used to that being our mechanism to get the software to talk back to us. And then we have our log aggregators and we go searching and we try to find it. So it's a matter of degree. We also use monitoring, and we make the hardware or different software on the hardware. And sometimes our software emit like how many requests did we receive,
Yeah.
and we try to like aggregate how long. So we have some ways of seeing, and we have some observability. Observability being defined as the innards of the software telling us what's going on, making the inner workings visible outside the system, specifically to the operators, not to like the users. They have their own interfaces. So it's a matter of degree, but modern observability, like state-of-the-art observability, emits events that can be constructed into distributed traces and also aggregated into graphs. And so you don't need your time series database. It's still useful for metrics like CPU load and memory and file system size. Those are like the weather. But for what my software is doing, I can emit events like, okay, I received a request, it took this long. And then I can aggregate over those with whatever statistic I want, P90, mean, um, how many were over 2 seconds and how many were under, what is the status code, all of these things. Our software can tell us all of that stuff, and then we can put that together into traces that show the connection or graphs. Right. So that's modern, like state-of-the-art observability. And people do that. People are doing that. It's getting easier, but it's not trivial. It's especially not trivial to like get older applications, get legacy applications that we don't deploy very often. It's hard to get them to emit the events and to connect the traces because you've got to get them like send every HTTP request or network request has to like propagate the trace ID. So that you can put all these things in context, construct the causal tree, and show it to people. But it's getting easier and easier. There's Open Telemetry is a big open source software project that's producing libraries for all the languages and all the different web frameworks and all the different database clients
Yeah.
to emit these events so that we don't have to do many code changes.
Yeah.
But also, I mean, standards. We have standards, and our standard right now is logs and metrics, and we haven't experienced better.
So the other question, I guess, or the thing that I observe is that we have a lot of this in I know observability. You saved me even having to ask the question because you went into observability, which is great. But I can see that we have a lot of this fantastic capability. But what I see with organizations and I see with teams is they're not given the space to create that or to put that in place. So they have to fall back to the base standard stuff that we have until something goes wrong. So
Yeah. Incidents are our friends, never let a good disaster go to waste.
yeah, so true. But my thought around that is, how do you talk better to organizations, to teams, to leaders, to give the teams the space to put these things in place? It's only going to make it better in the long run.
You know what? Incident response is seriously our friend here because if your software being up and running smoothly is connected to money, then we can convince the business to invest in like really good observability. I don't think the business understands the process of development enough to realize how much our understanding of the system affects the speed at which we can work. I don't know how to get them to appreciate that if they don't already, but they can appreciate downtime. They can appreciate how long time to recovery, how long it takes to troubleshoot an incident and figure out what went wrong. If you have a trace and you can see right where the error happened and you can see where the disconnect was, you can fix it quickly. But when you're digging through, you've got metrics and you've got lumps and you're guessing which lumps go with which other lumps. And then you're digging through logs and hoping that someone understands the logs well enough to read them. That's where the pain is that the business can see. And that's why most observability implementations start with ops. And then when the developers get involved, then they can add just a few lines here and there, like, hey, put the customer ID on every span. And then we can tell who is affected by this outage. Put the number of products in the order on every order span. And then we can see how much longer it takes for as cart size grows. I don't know. The little pieces that are pieces of data that are specific to this application are really valuable. I mean, anything you would log, if you throw it on a trace, then you get it in context, you can aggregate over it, blah, blah, blah. in Honeycomb anyway.
I think
It's not.
I think you said a very key thing there. Is I just want to grab before it goes too far away. Is translating it. So I see teams or development teams struggle to translate it to the business return, and I think that's an important thing there. That's really necessary if you can translate that to downtime, if you can time to reconnection, time to etc. Then the business has a quantifier that they can say, that's why we want to give you the time and space or the effort for that.
Yeah. Well, and we used to have to fight for time and space to write unit tests. And I don't think we do anymore. I think we just write them.
Yes.
I hope.
Well, I hope
Most
so.
places. The future is not evenly distributed.
Yeah.
So we just write unit tests. That's part of it. And as our standards go up, and also as the basic auto instrumentation is in place and it is just one line of code, it's not more lines of code to add the customer ID and the number of products and whatever else is relevant to your domain into the spans that you already have. It's then it is to write a log statement. It's the same thing, except better. But getting that infrastructure in place is something companies are doing, and they are doing it. Gartner, is it Gartner that publishes the adoption curve? No, they have the Magic Quadrant. Anyway, observability is early majority on the adoption curve.
Yeah.
I think.
You can see that happening. That's why I was keen to ask you about it, because there's a lot of organizations still looking at it and going, should we, shouldn't we?
And a lot of organizations are slapping the name observability on what they already have, which is logs and metrics.
Yeah.
Which is true. Those are observability. They're just crappy observability.
Exactly. Just I'm gonna. I love talking about that. You said something about product as well, and I want to delve into your other passion, which is product teams.
Right, because developers can be satisfied with logs and then not even look at metrics when all they care about is works on my machine, works in test. But if you're if you're adding attributes to spans instead of debug logs, then you're able to test in production as well. So at Honeycomb, we have this big thing, I test in prod. And I wore that t-shirt to the big Agile conference a couple weeks ago in Nashville.
I can imagine the lipstick that one.
It makes people really nervous.
Yeah.
But we don't only test in prod. Of course, we test before prod in multiple ways. We test locally, we test in CI, we test in our local dog food environment, our internal dog food environment, all before it goes to prod. But we also test in prod. We go find out whether it works. We find out whether people are using it. As a developer, this is really satisfying. I know I can go into Honeycomb and look at who's using this feature. And I can see the adoption increase, maybe if it is. I can see how slow it is. I can see the effect of my work on real customers in production. And you need that if you're going to have a product team. Because the point of a product team is that we don't just develop features. We deliver valued capabilities. And we provide those capabilities in an ongoing basis. And that means we have to be able to see into not just hypothetically, if they push the button, will it do what we specified? We need to know whether they're pushing the button. Because if not, well, shoot, did we make that button visible? Or did we ever need it? We need to be able to see that. And that helps us make decisions about where does the software need performance improvements? Where is it giving errors to people in production? Because where are they hitting validation errors and getting confused? All of that stuff is how we make our software better. Product teams take responsibility for their software. It doesn't have to be customers either. It can be internal. If you're part of the value stream, sometimes it's a service team, service ownership. when we take ownership of our software, that means we care about production. That means we need to be able to see what's going on.
Let's talk a little bit about product teams. Off air, we were just chatting about that a little bit. And one of the things that we both went, better not forget that, is not everything has to be a product team, right?
Oh, right.
And I think at the moment there's a real bent to everything's about product teams.
Well, I mean, project to product is the new agile transformation.
Yeah.
Definitely. Okay. I got something on this. The other day, I'm reading in my book, which is called Critical Systems Thinking, about the viable systems model. The viable systems model purports to be, these are the components that every system needs in order to be viable, meaning it can survive in an ongoing manner in a changing environment. So as self-sustaining and self-reproducing, a system that can keep going even as its environment changes, which we all want our companies to be, right? We know the economy changes, lots of things change. New versions of our libraries are released every day with security fixes. The world changes, and we need to be viable and go forward in it. So a point that this book makes, or the viable systems model makes, is that within a business, there's various layers, and one of them, he calls them System 1, does the work. So in a car manufacturer, some people are making cars. And in a software company, some people are making software. And I would argue that the software that goes into the cars also counts. And the teams that are doing the work, that are part of the value stream that affects the customer, also need to be viable systems. Not just the teams, the business units as well. Because you'll have a business unit that writes software to go in the car, and a business unit that assembles cars. And each of these needs to be a viable system in its own right. So those are system 1, but there's also systems 2, 3, 4, 5. 3 and 5 are like management and leadership. 4 is developer relations. Also marketing and sales is interfacing with the outside world. Systems 2 is support. So this is IT. Where do I get my computer? This is HR. How do I hire people? This is accounting and legal and platform. And all of the teams that are there to help the various System 1 units not get in each other's way and coordinate with each other, and just kind of like function more smoothly. Those should not be viable systems in their own right. So when marketing gets big enough that it is starting to preserve itself, right? Then it has to be able to blame the development teams for not meeting the deadlines. Okay, don't go there, John.
Which is normal, but yes.
But when you get HR that's there to sustain itself, it's not its stated purpose, but effectively the purpose of a system is what it does. HR will just preserve its own policies and make everyone else conform to it. This isn't healthy. This is where we get bureaucracy and red tape. So not every team needs to be a product team. A product team needs to be viable in and of itself. It needs to be multifunction and have everyone it needs in order to succeed. And by succeed, I mean provide valued capabilities. But not every team needs that. So your platform teams, for instance, if the platform team is viable and preserving itself, then it's probably like requiring everyone to use it. That's a failure.
Yeah, indeed.
It's okay for a product team, which is its own viable system, to buy its own cloud services and do the platforming that it needs internally. It's not okay for the platform team to be about itself, to make everyone use it. That's just right. So not every team needs to be a product team. Not every team needs everything. In another, I mean, okay, when I talk about a viable system, not every team needs to be that. In other ways, platform teams need to think of themselves as products because they need to be offering a service to the organization, not forcing it on them, which is a different way to think about product teams.
Yeah.
Um, but yeah, team topologies divides the teams up into, you've got your value stream teams. Those are the ones that need to be viable systems and multifunctional. And the company exists for those teams to exist.
Yeah. Yeah.
And
Correct.
then there's other teams. There's like enabling teams and platform teams. They exist in order for the value stream teams to do their work, not the other way around. So yeah, there are different kinds of teams. I love the book Team Topologies.
Yeah. Matthew's been on
Cool.
with us, and yeah, shout out to Team Topologies, and when we were creating a remote agility framework, certainly was a thought on us, because we sort of define it in 3 layers as well. We look at it as mission teams who short, sharp, they've got that mission that they've got to create, get it done. You have product teams, but of course, don't forget operational teams, right? Because everybody does.
Yeah, but the operational teams, it needs to be like, it's not about us.
That's right.
And a lot of the really senior developers wind up going to platform because you get good at software, you go meta and you start writing software for people to write software, like working at Honeycomb. But it has to be not about you. You're not the purpose. You're not the reason the system exists. You're there to support the value aligned teams.
Very wise words from Jess. Jess, we're very close to the end of our time. How can people get in touch with you? How can they hear you talk or get involved in Symmathacy?
So I'm on Twitter as Jessitron, Jessitron. That's where I hang out. You can also find jessitron.com, where you can sign up for my newsletter or see my blog. If you want to talk in person, honeycomb.io/office-hours. And all of our DevRel team we have Calendly's up, and you can just come chat.
Brilliant. Look, it's been fantastic to have you on all the remote things. If you're listening to this, don't forget to go subscribe so we can keep this thing running. Join our remote agility framework community that we've got in place. Just go to remoteaf.co, click the community button. You'll find lots of wonderful people in there that are really coalesced around thinking how we make remote and hybrid work better. And Jess, it's been an absolute fantastic time to have you on all the remote things. Thank you.
Tony, thank you so much for asking me questions and listening to the answers.
It's been my pleasure.